back. So one small note, important note, optional parameters. Okay. Sometimes we want to define functions with optional parameters. That is, the user might not want to give in some number or whatever. You want the ability to run a program even when the user doesn't want to give you a value. All right. In this case, a caller can choose to send a value for such a parameter, but otherwise a default value is substituted. So what are optional parameters good for? Coming up with a default value. For example, start here, define countdown. Okay, let's write this down. You will see what this is. Define countdown. It starts at 10 and ends at 1. What does that even mean? Equals 10, that is the default start. Equals 1, that is the default end. Okay, if the user does not give you a start, it does not give you an end or a start, then the code will use 10 and 1. That's the point of it. Okay, it's tricky but beautiful. Okay, you check this yourselves. Countdown, start is 10, that's the default. End is 1, that's the default. Okay, colon gives me an indented line again. For count in range from whatever start is given until end minus 1. You see, I want that end to also get printed. That's the point. And step minus 1, it's count down. So presumably start is bigger than end and I'm going down. What are we going to do? Print count. All right. Save this. Notice I don't have to hide any of these functions because I'm simply defining them. I'm not invoking them, any of these, right? I'm simply saving them when I run this file. Okay. Suppose I want to say count down 20 to 5, right? It started at 20, went until 5. Notice I want 5 also to get printed, and that is why whatever number I'm ending with, my range goes 1 less, because in a range the second number is never hit. So I'm going 1 less to make sure end is captured. All right. Now I gave it default values. If I don't give it anything, you see, then it starts from 10 and ends at 1 because those were the default values I gave. Suppose I give it only one default value. Which one will it choose? Okay. The one that I gave was assigned to the very first parameter. That's how it goes. All right. So I hope these are clear to you. All right. So now case study, we want to start computing square root ourselves. You know our math library has a square root function. But there is something called Newton's method. Those of you going through calculus, you probably have, I'm sure you have encountered Newton-Raphson method or Newton's method. You go over the details of the Newton-Raphson method and you get a guess. You get to guess and improve upon the guess by this formula. Okay. If your guess is a square root, then guess times guess should be the number, right? In other words, number over guess should be guess. I hope it's clear. Guess times guess is number, means number over this guess is the guess. So we have to get better than, if my guess is not good, I'm taking the average of the two, guess and number over guess. That's what this is. This plus this over 2. Okay. So this is a simple square root approach for any number. So notice we are not using the math library. So we want to be able to write our own functions, our own libraries. So let's start. So here are many examples of our functions, but I don't want to use this file. I want to start a new file, call it square root examples, right? Examples of square root functions. So my file name is going to be example square root dot py. Okay. So my first example is square root a of a number. Okay. So that is my formal parameter. This is def. This is the definition, the name of my function. Okay. Don't forget colon. Gets me an indented line, so that means I'm within the body of my function definition. Start with guess equals 1.0, so that means I'm in a float world, right? While guess is not equal number over guess, that is, my guess is not a square root. That's what this means. Then improve my guess to be guess plus number over guess the whole over 2.0. So this is improving my guess, right? And then don't forget to return, but don't return within the while loop. You have to be aligned with the while, okay? Not indented, aligned. Return guess. That is your first attempt at a square root function. Let's save this. So I want to save it as not here in the Dropbox. Teaching seems to go through this rigmarole all the time. There you go. So example square root. Okay, it's a .py file, so that's good. Now let's run this. Okay, it's just run. So let's try. This code will get us into an infinite loop because we can keep improving our guess. All right, let's see what that means. So square root a of 25. Aha, it gave me something quickly. Square root a of 16. Aha, it gave me something quickly. But does it give me a good approximation of square root 17? It did. A of 18. Now it's stuck in an infinite loop. Okay? Sometimes you are able to get it, but sometimes you are not. So this is actually an approximation which worked. Sometimes even the approximations, well, you keep going farther and farther away. You have to keep improving. So how we got into an infinite loop here. All right. So that's why it's waiting. So how do I break out of an infinite loop? Control C. All right. I had to interrupt. Look, that's where it kept getting looped up. All right. So we need to improve it. That is, we don't want an infinite number of improvements. We want to make it, say, a finite number of improvements. So I'll continue in the next video. All right.